Hello and welcome to C++ Weekly. I am your host, Jason Turner. I am available for code reviews and on-site training, but you probably already know that. I want to remind you that you have 1 week to sign up for my ACCU on C Best Practices class. This episode is one that was also requested by a user, and it is all about devirtualizing virtual functions through the use of final. This is a topic I believe I've danced around in previous episodes, but I don't know if I've ever directly demonstrated it on C++ Weekly. Probably have, not sure. This week's episode is sponsored by HRT. If you've attended any C++ conferences this year, there's a good chance you've already heard of HRT, as they have sponsored several conferences. HRT is known for its deep engineering culture and strong focus on performance, and they are looking to hire the sharpest engineers to help them to develop and optimize the technology at the core of their business. They're headquartered in New York, but they have offices in Austin, Chicago, Boulder, London, Dublin, and across Asia. They're looking primarily for C++ and Python developers. I know, since you're a viewer of C++ Weekly, you are a C++ programmer, and you probably already program in Python too. So go ahead and check out the link on the screen for openings that they have. And remember, you don't need a financial background, just strong engineering fundamentals, and they'll teach you the rest of what you need to know. Say I've got some base class. I've got some virtual function that returns an integer. Derived is derived from base. Derived, by the nature of the design of this code, will have a func member, and base will have a func member. Now, I have intentionally not provided either one of these because I don't want the compiler to optimize away the example entirely. I am providing this function with a reference to a const base object. And this little hop here is the compiler loading the vtable and then jumping to the appropriate function that's at the first entry of this vtable. You can see here I've changed it to call other, and now this is rax plus 8. It is calling the second function in the vtable, one address offset. Right now, it must make this vtable call. If I were to provide in derived here, let's change this. We're going to make this a derived. We're going to change the name of this to obj. There we go, obj.other. Object of type derived. This is still going to compile. It's going to do the exact same thing. It has to do this offset into the vtable. Now, if I tell the compiler that I'm providing my own implementation of other, that doesn't really change anything here. It still has to do this vtable offset, because it's entirely possible that what I've given it is some object of type more derived that has its own implementation of other. Now, let's go ahead and make this a little bit more correct. Let's make these override. Override is a very important feature of C++11 that helps keep our code nice and safe and clean. It doesn't change the meaning of the code at all here. It just enforces our expectation that we are in fact overriding a member of a base class. I'm going to comment this out, and the compiler still has to do this vtable jump. If I were to change this to final, then at this point the compiler says I have an object of type derived. I am calling the member other on an object of type derived. Other is declared final in derived. Therefore, I know that it is no longer possible for anyone to further override this particular member, at which point it can now directly call this and devirtualize that function call. If I remove the final from here and playing the same game, I say that this class is final, and that means that it cannot be further derived from, which will give us a compile error down here on more derived. Then it knows that it is just going to call the derived whatever const, right? It knows that that's the only possible option. So what happens if I call func instead? I am final, but I don't provide my own version of func. Oh, look at that. It knows that the only possible option is to call base class's implementation of func. So yes, final on either a member function declaration or on a class type declaration can in fact affect the compiler's ability to devirtualize these function calls. I'm going to turn off optimization, largely just to see what happens here. Yeah, look, even with optimization off, it still knows that it doesn't need the vtable call. GCC is kind of aggressive a little bit in some of these things in ways that I wouldn't necessarily expect it to be. So let's see what trunk of Clang does. Trunk of Clang also avoids the vtable call. Very good. All right, so there you are, optimizations enabled or not. Using final, yes, it is in fact possible to generate more efficient code. Thank you for watching this episode of C++ Weekly. Be sure to subscribe. I'll catch you next week.